Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6J assignment. Okay, number one, when Andrew dives off a pier, his height above the water after t seconds is given by this here. Okay, how high above the water is the pier? Okay, so what we're going to have to do is figure out what our the height of this pier is going to be. So really what that's going to be here, that's represented by this positive 3 right here. Because let's see, this here is gravity, the effect of gravity here. And so you're starting at 3 meters above the water. Okay, so the height above the pier is 3 meters. How long does it take for Andrew to reach the maximum height of his dive? Okay, so we've got this quadratic. We want to find... basically, we've got, ooh, that is terrible. There we go. So basically, here's Andrew. Let's call this, here's the height of the pier, and this is going to be our representation. This is going to be his height above water, right? And then this is going to be time. Okay, it looks something like that. So that's height in meters above the water. This is time in seconds. Okay, so we want to know what this point is right here, right? So that's the vertex, right? So we were going to want to use, for B, we're going to want to use x equals negative b over 2a. So in this case, negative 4 over 2 times negative 4. So x is going to be negative 4 over negative 8. So x is going to be 1/2, okay, or 0.5. So how long does it take for Andrew to reach the maximum height of his dive? 0.5 seconds. So he's going to go up for 0.5, and then he's going to come back down. How far is Andrew above the water at the highest point? That's going to be this y coordinate. So we just simply are going to plug our 0.5 into this equation and see what we get, right? So the height at 0.5 is what this is saying. Remember, this 0.5 does not get multiplied by the height, so most people elect to leave that off. I kind of like to have it in there because it just tells me what I'm finding is negative 4 times 0.5 squared plus 4 times 0.5 plus 3. Okay, so this height is going to equal 0.5 squared is a quarter. Negative 4 times a quarter is negative 1. Half of 4 is 2. And then plus 3. So his max height is going to be 4 meters. Okay, 4 meters. And then how long does it take for Andrew to hit the water? So that is when his height is back at 0, right? So for D, we want to know when the height is 0. So when does 0 equal negative 4t squared plus 4t plus 3? We could try to factor this out, and it might actually factor, but I know that for a lot of these, the factoring isn't going to work, so I'm just going to plug this into the quadratic. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I know this will always give me some kind of answer here. Okay, x equals, so let's see, a is negative 4, b is 4, c is 3, right? So x equals negative 4 plus or minus the square root of 4 squared minus 4 times a, which is negative 4, times c, which is 3, all over 2 times a, which is negative 4. So we get here x equals negative 4 plus or minus, and then in the root here, let's see, underneath we get negative 8. 4 squared is 16. Negative 4 times negative 4 is positive 16. Times 3 is 48. So that turns into negative 4 plus or minus the square root of 64 over 8, negative 8. So x equals negative 4 plus or minus square root of 64 is 8 over 8. So we're going to get x equals negative 4 plus 8 over, negative 8, or x equals negative 4 minus 8 over negative 8. So this one here, negative 4 plus 8 is 4 over negative 8. This gives us negative 1/2. Can't have negative times, so that doesn't work. That's basically this part right here. And then this one here, negative 4 and negative 8 is negative 12 over negative 8. So that gives us, let's see, 1.5. So it's going to, how long does it take for Andrew to hit the water? 1.5 seconds. Okay? Okay. Let's take a look at number 4. 3 sides of a rectangular paddock are to be fenced, the 4th side being existing straight water drain. Okay, so basically we've got one side of this paddock is this water drain here, this water pipe, right? So that's our existing piece with the water going through it. 1,000 meter of fencing is available. What dimensions should be used for the paddock to maximize its area? So basically what they're getting at is we've got this here, and then we're going to build this rectangular fenced off area here with 1,000 square meters. Sorry, 1,000 linear meters of fencing. Okay, so let's call this here X. This will be the same X, and then this will be Y, right? So let's just say we choose this. Let's say if we know that this side here is X, we know we have 1,000 total meters of fencing, right? So this Y is going to be the same thing as 1,000 meters minus these two X's. That's going to be the same thing as Y, right? Because we know that we have 1,000 total meters. So like, let's say if we use, just for example, 200 meters here, that means 200 meters here. So we would do 2 times 200 is 400. And we do 1,000 minus 400. 400 would mean we would have 600 left for this right here. Okay, that's why it's 1,000 minus 2x is the same thing as y. Okay, now let's get rid of that so that doesn't confuse us later. That was just a for instance. So we now know that the area of this here is going to be x times 1,000 minus 2x. Okay, and I know that that's a little bit of a leap, but actually did an example just like this in the notes. So if you watch that, that should hopefully help out. So we've got the area is going to be 1,000 minus 2x all times x, right? So the area is going to be 1,000x minus 2x squared. Okay, now what we want to do here is I'm going to just plug this into x equals negative b over 2a because we are trying to figure out how to maximize its area. So basically this here is going to be negative 2x squared. This is going to have some kind of like negative graph here. We're looking for this point up here. Okay, so a is negative 2 and b is 1,000. So we've got x equals negative 1,000 over 2 times negative 2. So that's negative 1,000 over negative 4. So that's going to be 250. So we know that this is 250 and this is 250. So then this is going to be 1,000 minus 2 times 250. So that's 1,000 minus 500, which is going to give us that this here is going to be 500. Okay, so what dimension should be used for the paddock to maximize its area? 250 by 500 would be our max. 250 by 500. Okay? All right. Let's take a look at number 8. Shape of this tunnel can be described by the quadratic model ax squared plus bx plus c. The units are meters. Find the value of a, b, and c. Hence, state the quadratic model which describes the shape of the tunnel. Okay, so here's our y. Look, right up here, positive 8. That's going to be, that's going to be our c. Okay, so c equals 8. Okay, now what we're going to want to do is we're going to find the b and the a. Okay, so the axis of symmetry is the y-axis here, which is x equals 0. So we know that for part 2, we know that x has to equal 0. And since we start off with x equals negative b over 2a, we know that this b here has to equal 0, because the only thing that we can, only number we can divide by any other number and get 0 is 0. So 0 has to be b, so b has to be 0. And then now that we know those two things, we should use those to try to help us find out what a is. We know for sure it's going to be negative. Okay, so let's see what we can figure out. For that. Let's see, we know this point right here is at 0, 8. Okay, so let's do this. We got y equals ax squared plus bx plus c. We now know, we don't know the a yet, but we do know that when x is 0, y is 8. So 8 goes in for y, 0 goes in for x. And then let's see, we already know that b is 0, and then this is 0 also, and then plus c is 8. Now let's see if we can solve that. Ooh, that doesn't really help us much, does it? Because that's 0, and 8 equals 8. Yay, that's true, but that doesn't help us. Okay, let's try this instead. We can actually use either one of these points here. So we know that this is 3, 0. So let's use that for x and y and try that instead. So we get y is 0 equals a times 3 squared plus, we know that b is 0 times 3 plus c, which is 8. Okay, so we get 0 equals 9a. That's a 9a squared. Sorry, not 9a squared, but just 9a, right? Because 3 squared is 9 times a is 9a. That's 0 plus 8. Subtract 8 from both sides. Negative 8 equals 9a. Divide both sides by 9. And we get a is negative 8 ninths. So now we have all three pieces, hence state the quadratic model, which describes the shape of the tunnel. So it's going to be y equals negative 8 ninths x squared plus 0x, so we don't even have to include that, plus 8. That would be the equation of this tunnel here. Okay, that one's a little trickier, but just keep trying stuff out and see what you come up with. Okay, and then number 10 here, a stone is thrown up in the air from the top of a cliff 60 meters above sea level. Stone reaches max height of 80 meters above sea level after 2 seconds. Okay, so let's draw ourselves a picture here. So we've got this here. Here's let's make this our cliff. Okay, so we know that this is 60 meters tall, 60 meters. Throws a stone off the top of the cliff. And again, this is basically not necessarily the path of the rock, but this is time and this is height. We know that at 2 seconds it's at 80 meters above sea level. Okay, the stone's height above sea level after 2 seconds could be modeled by this here. State the value of c. So c is our y-intercept, so c has to be 60. Okay, use the remaining information to write 2 linear equations involving a and b, and then find a and b. Okay, so let's see, with this info here, okay, we know that this is 60. This really here is at 0 and 60, right? So let's write 2 linear equations involving a and b. Okay, so we also know that straight across over here would have to be, so this is our axis of symmetry. So if it takes 2 seconds to get here, it's going to take 2 more seconds to get here. So this is going to be at 4 and 60. Okay, so this one here, let's use these 2 points to come up with our other 2, our remaining information to write two linear equations involving a and b. Okay, so let's see if we've got the height is, if we use this 2 and 80 first, 80 equals a times 2 squared plus b times 2 plus, we know c is 60. And then let's simplify this, subtract 60 from both sides. And we get 20 equals, 2 squared is 4, so that's 4a plus 2b. Okay, and it looks like we can divide all of these evenly by 2 to simplify a little bit, and we get 10 equals 2a plus b. Okay, now we can also use this other point over here, which is 60 equals a times 4 squared plus b times 4 plus 60. Subtract 60 from both sides, and we get 0 equals, let me back up here a little bit. 4 squared is 16a plus 4b. We can also take a 4 out of all of these, factor these all by 4, and we get 0 equals 4a plus b. Okay, so now we have two equations with two unknowns, and now we can go through and solve this. Okay, so let's line these up. I'm going to put this 10 equals 2a plus b over here. So if we simply multiply one or the other of these by negative, so this would be 0 equals negative 4a minus b, and then we still have this 10. Just move this straight over. 10 equals 2a plus b. When we add these together, the b's cancel out, so we get 10 equals negative 4a plus 2a is negative 2a, divide by negative 2, and we get that a has to, not 9, but a, that was terrible. Let me try that again. A equals negative 5. Okay? And now that we know that a is negative 5, we can plug it into either of these equations to figure out what b is. I'm going to plug it into this one right here because we know that 0 equals 4 times a, which we now know is negative 5, plus b. So 0 equals negative 20 plus b. Add 20 to both sides, and we get that b equals 20. So a is negative 5, b is 20, and c is 60. So our equation is h of t equals negative 5a, t squared plus 20t plus 60 should be our equation. Okay? All right, I know that's a tougher one. I know that that's a bit of a reach, but we can do this. The big key here is just trying to find a couple of points in here that we can use, because if we use this one here, we would just get 0 equals 0 or 60 equals 60, and that's not very helpful. But this over here is the one that actually gave us a new, different equation. Okay? Okay, that's all we have for this one here. If you have any further questions, please feel free to ask. Thanks.